Right, so what we have here, we have to find the domain and range of the two functions in A and B. F of z equals 2 times the real part of z minus iz squared. B is f of z equals the square root of z. We're going to find u of r and theta and v of r and theta in each case. Right, do this successfully, then we have f of z. 2 into the real part of z minus I z squared. From this point is you let z be x plus iy. And this is exactly the same as r into cosine theta plus I sine theta. So this is twice into cosine theta plus I sine theta. Minus I into minus IR into cosine theta plus I sine theta. Okay. So you have this. So what do we get out of this? Now, this one here is actually exactly 2 into the real part. That's what you're going to take. So the real part is going to be r cosine theta, twice r cosine theta. So it's twice r cosine theta. Right. And moreover, we have minus I. We square the r. And if we square the cosine, it becomes therefore exactly cosine squared theta plus I 2. Okay, I2 into cosine theta, sine theta, minus sine squared theta. Like so. Okay, this is exactly what we get. This is precisely what we obtain out of this. Let's just rearrange the terms, so group terms, like terms together. Okay, so we have here at this point twice r cosine theta. And then now what do we get out of this? And then you have twice. Okay, that this is the 2, but I and minus I and I is going to give us 1, so it's 2r squared into cosine theta sine theta. Like so. Okay. And you can put these in parentheses and we have the I terms. So the couple of items that we have. Right, so in view of the items, we have, for instance, plus, you can put plus I into. Right, so this one is going to be r squared. And then you can put a minus here. There is a minus. So it's minus r squared. Okay, then moreover, then you have this when you multiply out with the minus, when you multiply out with the minus, or you can write out like this. Let's just write it in this manner. So this, you can just leave out the minus IR squared. Into cosine squared theta minus sine squared theta, like so. Okay, now what is this? So from this, we're able to see hence that d of r theta cosine theta to r squared cosine theta sine theta. Okay, the v is minus r squared into cosine squared theta minus sine squared theta. Okay, this is what we obtain here. We'll proceed. Now, there are a couple of realizations we can make. So this also can be written as follows. Because cosine squared minus sine squared is cosine 2 theta, this can also be written as minus r squared cosine 2 theta. Okay, we asked a couple of questions about the domain and the range. Let's just clarify that, because surely from both representations of the function, you can see that both of these are continuous and continuous everywhere. And therefore, we can see that we can say that the domain is complexes, the set of all complex numbers, and the range is the same. Okay, the range is all complex numbers. Okay, f of z. Right, at this point, this one you can write as r. Can write as r e to I theta. R e to I theta. In which case, therefore, this is the square root of r e to the I theta over 2. And what is f of z? So this is the cosine of theta over 2 plus I, the sine of theta over 2. Right, from this, we are able to make a couple of observations. We can be able to write, for instance, the following. Okay, it's Euler's formula that allows us to convert the e to the cosine and the sine representation. This one is r, the square root of r cosine theta over 2. Okay. So this one here is theta over 2. Okay, so yeah, all right. Can write like that. Plus I into the square root, into the square root. I the square root. So you have the sine of theta over 2. So at which point you have the cosine of theta over 2. And this is the square root of r, the sine of theta over 2. Okay, we ask the questions in terms of the domain and the range. Let's just answer those very quickly. So at this point, you can be able to see that the domain is the set of all complex numbers, because of all complex numbers, this square root function is defined. Then what about the range of this function? So the range of this function is certainly all complex numbers, because what we have here is that these two trigonometric functions can both be negative or positive, but the square root for very large complex numbers, the modulus is also large, in which case generally these will cover the complex numbers for both the domain and the range. And we have these particular results here, with these results. I'm done. Thank you, everybody. Goodbye to you.